Okay, so now that we have our degree analysis and different applications of degrees in mind, we can now look at a new type of measuring system. So let's look at radian measure. So this method is a little different than how they basically chop up a circle into 360 parts to get a degree. This is a little different. So another means of measuring angles is by relating it to an arc of a circle. So an angle with its vertex at the center of a circle that intercepts an arc on the circle equal in length to the radius of the circle has a measure of 1 radian. What in God's green earth are they saying? Well, a picture will illuminate for us. So let's first draw a circle as best we can. So we have our circle. Now, if we find our center here and we have a radius, let's do a radius that's similar to our coordinate system. So we'll say there's one of its sides. And now let's read it again. So its vertex is at the center, so there it is, with a circle that intercepts an arc on the circle equal in length to the radius of the circle. Okay, so we don't know what the radius is, but let's call it R. And so now it wants you to intersect an angle from the center of the circle that intersects an arc with the same length. So if I said, okay, if I wanted to just basically put this R onto the circle itself, where would it stop? So if it started going around the circle, it might maybe stop right about there. That's about the same length as the radius. So that angle would be right here. So they're saying this angle has a measure of 1 radian. That's the definition of radians. Kind of weird, I know. So you can kind of see that, you know, if you were to try to go around the circle, it would be a certain number of radians, maybe a little bit more than 6. But how much more than 6? Well, we're going to get to that. So if we were to find the number of radians needed to go around the entire circle, it would be 2 pi radians. So again, a little bit more than 6. You know, 2 pi is equal to 2 times roughly 3.14, so 6.28 approximately. It's not exact. So approximately 6.28, so a little bit more than 6. So that's how many radians it would take to go all the way around the circle. So we now have this equivalency. So 2 pi radians is equal to 360 degrees. And with that, we can get a lot of different conversions. So if we cut this in half, obviously we'd have pi radians should be 180 degrees. And if we cut that in half, pi over 2 radians should be 90. And if we triple that, we should get 270, so 3 pi over 2, and so on. So we get all of these different conversions that are fairly natural in how they occur. But what if you wanted to get a conversion for any angle or any radian measured back into degrees? How would we do that? Well, we kind of have to use what we've established here. But let's use the easiest one. If we want to convert between degrees and radians, we can use this relationship that pi radians is 180 degrees. So when we're going one direction, specifically when we're going from degrees to radians, we would multiply by pi rad over 180 degrees. And if we're going the other direction, changing from radians to degrees, we're going to multiply it by 180 degrees over pi radians. So it's one way or the other to get those units to cancel out. So looking at 150 degrees, I would start off by just putting it over 1. And so if we put that over 1, now we can see if we want to get units to cancel out, we're going to need the degrees down in the bottom. So we're going to have to use this first conversion. So pi rad over 180 degrees. And so now we can do a little bit of reducing, so we can cancel out the zeros. 3 goes into both of those, so it looks like 5 pi over 6. Now, sometimes including the units of radians is important. Other times it's not. It depends on how the problem's worded primarily. But if you're not sure, it doesn't hurt to put that in there. So that way you know it's in radians. So in this case, we got pi over 8. It's kind of small there, I know, but so now, technically, if you wanted to, we could put the rad up in top. Because think of units like a number. You can put it over 1, so we can put it on top and maybe put a 1 down the bottom if you want, but whatever. But now you can see, because the rad is on top, we need the rad that's on the bottom. So the 180 over 80 degrees over pi rad is going to work for us, because now those are going to cancel out completely. And so we can just divide 180 over 8. So which is what? 22.5 maybe? So 22.5 degrees. So again, the degrees are the only units left, so that's why we need to make sure we include them. The only units left here are the rad, so that's why we have to include them. But like I said, sometimes they'll leave them out. So it's implied, because there's no degrees in there, it's got to be radians. Radians is the default. Okay, so now we have a little bit of understanding of how radians work, but now let's apply some of those other applications using radians. So this next one says to find positive and negative angles coterminal to the given angle. Negative pi over 6. Now we could do this a couple of ways. Some people are very phobic to using radians, and especially fractions, but we shouldn't be scared of those. We can do this with fractions pretty easily. It's almost going to be a little bit faster than the other method. And the other method would be to change this into degrees and then find your angles and then change them back into radians. Seems like a lot of extra work just because you don't like radians. So let's do it the easier way. So let's start with our positive. So remember, when it's positive, usually we like to add 360. But what is 360 in radians? Hopefully you haven't forgot already. It is 2 pi. So if we add 2 pi to that, we should be able to get to our answer pretty quickly. So adding fractions, we need an LCD, obviously. So let's get a common denominator of 6. So that should make this 12 pi over 6. And so a negative 1 pi plus a positive 12 pi better give us 11 pi over 6. And so our negative is going to be the same style. And since we know we are subtracting 2 pi, let's just cut to the chase. Let's subtract 12 pi over 6. So a negative 1 and a negative 12 is a negative 13 pi over 6. And we're done. Okay, let's do number 5. The complement and supplement to pi over 8. So complement and supplement. Complement. How do we find the complement? So remember, we know complementary angles should add to 90. They should add to 90. So in order to find what else we need to add to this to get to 90, let's take that away from 90. But 90 in radians is what? Yeah, it's going to be pi over 2. So if we subtract pi over 8 from pi over 2, that should be our answer. So we can quickly get an LCD for this. So 4 pi over 8 minus pi over 8 should give us 3 pi over 8. Now again, they didn't have units on the original problem, so we'll leave them off. And so for the supplement, now we just have to remember that they add to 180. Yeah. So in this case, we're going to use pi minus pi over 8. So that should be 8 pi over 8. So that's going to give us a 7 pi over 8. And there we have it. Now, I know this video is getting a little long, but we are on the last part. Let's finish this off, right? Okay, this last application is pretty short, but it's kind of how the foundation of radians was defined. So, arc length. So the length S of the arc of a circle with radius r intercepted by central angle theta is S equals r theta, where theta is in radians. So again, you could have any circle you want with any angle you want. So we know the angle is theta, but the length of the arc now is S. So that's the relationship for this formula. S equals r theta. So the length of the arc equals the radius times the angle. But the angle has to be in radians. So be careful. All right, so let's do these couple problems and we'll finish off this section. The length of the arc on circle S, radius r, or central angle as appropriate. So we got to find any one of those that's missing. So in this first one, they're giving us r, they're giving us the angle, so that means we're missing S. So S equals 15 times 120. What was I thinking? What's wrong with that? We can't use 120. We got to get it in terms of radians first. So we have our angle. Remember our conversions from up above. So in this case, if we multiply it by pi over 180, that's going to give us our angle. So we can see 60 goes into both of those. So it looks like it might be 2 pi over 3. So 2 pi over 3. And so we can do a little bit of cancellation in here. So looks like that's going to give us a 5. 5 times 2 pi is 10 pi. So 10 pi. Well, let's get a decimal. No point in leaving it in terms of pi. So 10 times pi. Well, 3.141592 is pretty close. Equals 31.4. All right, so 31.4, and now what are the units for this? It's an arc length. It's a length. How long is this? If we know the radius is 15 inches, then the units better be the same thing. So our arc should be 31.4 inches. All right, last one. S equals 150 kilometers. R equals 80 kilometers. So now we're missing theta. So in this case here, if we wanted to solve this for theta, we could quickly do that. We divide both sides by r. So we got S over r. So all we got to do is just divide those. So 150 over 80. Well, let's see what our calculator says. 150 divided by 80 equals 1.875. So 1.875. But what are the units for this? Well, we already know it should be in radians. So that's our units. So, all right. So that wraps up the first section. Again, trying to give you a little bit of a reminder and recollection of how degrees and radians all work in terms of degree measuring angles. So now that you have this foundation, we're going to apply some other techniques in the next section. So see you very soon.